Hello students, welcome back. We talked about linear correlations and we went through a lot of scatter plots. And then we went through this computational formula. Let me expand the font so that you can read this better. Where Sx and Sy are sample standard deviations of x and y. Now we just analyzed this. I'm not going to ask you to calculate this in any circumstance because this is absolutely crazy. So we're going to use technology to calculate it. So the formula itself actually of little use. What is useful then? This one. Correlation coefficient is always between -1 and +1, and moreover, r is greater than 0, then we have positive correlation. When r is strictly equal to 1, then perfectly positive correlation. That is, all the points are precisely on a line that is going up. When r is negative, then negative correlation, and when r is precisely -1, then perfectly negative correlation, which means all the points are precisely on a certain line and the line is going down. Now, what about r is pretty close to 0? In that case, very weak, little or no linear correlation, and r is precisely equal to 0, then we say no linear correlation at all. But there can be actually various different kind of situations, as a matter of fact. Linear correlation may not exist, but there can be some other kind of correlation, like parabolic or anything else, as a matter of fact. Of course, we are not going to deal with any of those in 1000 level course, so you don't really have to worry about anything at all. So that much is going to be sufficient for correlation coefficient. Now, let's go to how to calculate correlation coefficient and other quantities using technology. As for this mathematical notebook, well, I thought about it, but it's too hard. It's very powerful, yes, but it's too expensive and too hard. So let's talk about MS Excel. And we are going to use this example for that. Here's a score table for a certain class and produce the scatter diagram for midterm and the final exam score, and do the same with the homework score. Similar to previous example, but actually a little bit different score. The reason I used those class was because there was no pattern actually. That's why. In this case, you're going to see some pattern. Okay, all right. How to calculate the correlation coefficient? There are 19 numbers here, so 19 pairs here. So you don't want to do this. Multiply all those 19 times and then add up. And then as for standard deviations, again do this 19 times. After all, the squaring and the square root is absolutely crazy. So let's do this using technology. And you can type in all these into MS Excel notebook. But I just want this to save some time, so here we go. I have it already. Oh, by the way, let's cut it off. Okay, we have exam 1 and exam 2, and we already discussed in a previous video, not the previous, but the one before the previous video, in the first video, how to get the scatter plot. Number 1, select the data set, go to Insert, select Chart, and then I selected like this, so default chart is already scatter plot, but if you have something else, then you can go ahead and look for the scatter plot and then select the one color form, and that is a scatter plot that you're looking for. And also, if you want the line of best fit, the regression line, you can check this to get the trend line. But let's remove this. For our purpose, it's not really important at this moment. At this moment, we're trying to do the correlation computation. Okay, we're going to find out the correlation between exam 1 and exam 2, so let's go ahead and do that. When you're calculating, you have to insert the cell first. So, correlation between exam 1 and exam 2, this one and that one. Okay, alright. Select the cell, and in home, go to this sigma symbol with upside down triangle here. If you're in some other place, go to home and then look for this sigma notation with upside down triangle. Now, correlation is not here, so more functions. Most recently used is already correlation. That's because I'm a stat teacher. I recently used it. In general, you're not going to see anything like that, and you'll have to go to statistical. Okay. Everything that is necessary is in statistical package, and then go down to correlation. It's in C, right here, correlation. Select that, and correlation requires bivariate data, so you need 2 columns. So cursor is blinking here in array 1, select that column. I use mouse to do that, but if you prefer to type it in, go ahead and do that. Now let's go to array 2. If you just click OK, then you're going to get an error message because array 2 is missing. You have to get it. And then go to the other column that you want and click OK. That's a correlation between exam 1 and exam 2. Now, what if we switch the order? Upside down triangle, more functions, and then go to statistical and go to correlation. And then select exam 2 first, and then go to array 2 and exam 1. Oh, we have the same value. But then again, that's not surprise. There's no surprise there. Let's go to correlation coefficient computation formula. Well, multiplication is commutative, so if I switch the order of this times that, no change there. Switch the order of this times that, no change there. So there's no surprise there. So whether I do this first and that first, x first and y later, or y first and x later, no difference. Let's do one more exercise. Let's get the correlation between the average exams and projects. Average exam and project. Okay, so let's select this. These are not very good. Okay, so average exam and blackboards. So let's look at correlation between column D and column F. Okay, all right. So select the cell and then go to upside down triangle beside the sigma, more functions. And then if you are in some other place, go to statistical, and then look for correlation. Here's the first data set, average exams, and go to second data set, and you want, what do you want? Exams and project? Okay, project, okay. And there goes the correlation coefficient. I should have said column D and column G. Now, if I go here and then G first and D later, it's going to be the same. Project first and then average exams later is going to be the same deal. Go to correlation and then get the project first and then go to average exam scores. Compare. Not surprisingly, they are the same. So any two columns will do. Now, what if you want to create a scatter plot with exam and project? In that case, they are separated. Here, they are together, so it was easy, but they are separated. So it looks like we'll have to do this. Copy and paste it over here. And then copy and paste it over here like this. Okay, I cannot move it around. Okay, sorry about that. Let's delete this. Insert, and then, okay, move it here so that I made duplicate of this project to this right next to exams. So I can take these two, select those, and then go to insert, and then produce a scatter chart. So there's a bit of a difference between calculation and the scatter plot. For calculation, you have to select a cell first, where the number will go, and it doesn't matter where you put it actually. And then go to this, and then more functions and whatever, follow the direction, and then that computation will go to this cell. Now, as for the chart, you have to select the data first and go to insert. And for bivariate data set, you have to arrange this table a little bit so that those two data you're looking for, those should be together. Otherwise, you're going to have a bit of a problem. Okay, so much for calculating correlation with MS Excel. And let's see. Yeah, scatter diagram for exam 1 and exam 2 put together. That's how Mathematica got its picture. And as for MS Excel's picture, I don't know, let me check. Go ahead and check. No, we have to go to insert. Excuse me, I'm going to scatter chart. So this versus that, are they the same? Actually, they are the same. A little bit different scaling. You see, the grids are a kind of rectangular, even though they should be squares. So if you scale appropriately, then you're going to get exactly the same picture as before. So whatever you did through MS Excel is actually correct. Alright, we'll say section 2 is now completed. We'll meet again in section 3 in a separate video.